we have today with us Mr. George Lipsum, and
Thank you.
he is a retired NRC official and now consultant. I'll tell you a little bit about his career. He began in the military as a director of technical projects for the Naval Research Laboratory, creating software for Lawrence Livermore National Laboratory, as well as publishing for IEEE. He is a retired Navy and commercial aviation instructor pilot with 7,000 hours experience, a former member of the U.S. NRC Commission, and where he was a lead quality assurance inspector, expert witness, and nuclear plant licensing technical reviewer. He lives in the area now, and we are honored to have him come and to speak not only at our graduate research seminar, but then he will be here for the 5:30 American English Society student meeting. Thank you.
Thank you. Thanks for the introduction. It's great to be here. I've lived in the area for 20 years and been in the nuclear industry for probably around almost 20 of those years. And I remember thinking, I gotta get over to NC State and see what's going on with the nuclear engineering department. I finally made it over here. So it's great to be here and finally be able to share some of the things that I pulled together during my life experiences and hopefully share some new things with you. Today, we're gonna talk about the nuclear, what I call the nuclear extra, which has to do with QA and the industry, specifically with software. So we're going to drill down to that level. And what I'm hoping that you'll leave with today is after about 45 minutes of talking and losing my voice and about 15 minutes of questions, hopefully you'll leave with a good idea of one, what is this nuclear extra? What makes us a little different in the nuclear industry? The second area will be, how do we take the regulatory requirements in this very highly regulated industry, put them down to a licensee or a vendor within the industry and as to their quality assurance program, so how that comes down. And then the third area would be, okay, now let's talk about software and how all this applies to software, which that is becoming much more important now. So in my background, as Ms. Marshall said, I've been at the NRC for about a decade. I worked for GE down in Wilmington in their nuclear division. I was the INC supply chain leader down there. Currently an auditor, so I got into oversight roles. And one area that I kind of specialize in is software quality assurance. And one of the groups I work with is the ASME NQA1 standards group in their software subcommittee. So hopefully I'll bring those three areas together to give you some good information as we're going forward. Today, everything I'm putting up here is available for you to use, share, do whatever you like with. There's nothing specialized, classified, anything about that in there. I'll give some opinions today. I'll try to say, hey, this is my opinion, or this is what I think, just so you know it's maybe my personal opinion. But if you have other questions, certainly we can go into more depth if you like. So 3 areas that we talked about. We're going to cover that nuclear extra. What does that mean? How is software building into that nuclear extra? How is software going forward going to be more important as we move further down the line with digital plants? Second area, as we talked about, those nuclear quality assurance programs, I'm going to show you where the requirements come from. I'm going to show how they get down into your licensed quality assurance program. How many people have heard of quality assurance programs here at NC State? Anybody? A few? A few? Okay, so a lot might be kind of new for you, but you'll see where the requirements come from, which is hopefully what you're doing every day if you were operating a plant or something within the supply chain. And then the third area, as I said, will be the software. I know you do a lot of software work here. Software like your COBRA, CTF. COBRA I know comes from here. There's probably other people that specialize in software, so I'll give you some details in that area. So that the second bullet here will be kind of high level, third bullet a little more detail for software, and hopefully I'll give you some examples because otherwise it kind of goes right over your head. So I'll give you some examples, maybe give you some in the design analysis area because those are kind of very common areas that we would see. So the nuclear extra. In our industry, we have a very low probability of something bad happening, let's say at a plant. But if something were bad to happen, there might be a very high impact. So there's a lot of emphasis on risk. And to give you an idea, the NRC does a lot of calculations in the risk area, and they are now moving from up to the 1 in a million kind of chance that something what we would call a core damage accident would happen. 1 in a million. So it would be a million years for a plant, for instance, to have that happen. Now you got a lot of plants out there. So very low probability. But the downside is very important. So we keep our industry, like aviation industry, food and drug industry, very safe, and we have a lot of regulations that go with this. So part of the reason that we have been very safe and somewhat successful is what I call this nuclear extra, which is quality assurance. And the quality assurance I think of as an umbrella. That's programs that go over top of the activities that we do, whether you're designing, manufacturing, operating a plant, whatever it might be. It'd be an umbrella that goes over the top to help us do those safely, repeatably, and if there's ever a problem or something we can do better, a method is in place to help correct those things and make them better. So we'll talk a little bit more about that. In the U.S. industry, we've been very fortunate that we've had very few of these damage frequency events that have occurred. Overseas, you probably heard of some things maybe not as fortunate. Overseas, things like Chernobyl you probably heard of, Fukushima this more recently, things that have happened. But we in the U.S. have had situations that maybe weren't quite as bad, but were almost as bad, potentially could have been as bad, but we were able to mitigate those problems. Things like 3 Mile Island, you might have heard of that, back in '79. Things like Davis-Besse had degradation of their containment and their core, the cladding that went with it. Also, the Browns Ferry plant had a fire that could have been very bad if it had not been contained. That could have caused a lot of problems. So we haven't been perfect, but this nuclear extra helps us get closer to that. So to start, where do these rules come from? Well, we mentioned the NRC, the Nuclear Regulatory Commission. In the U.S., that is the primary regulating agency that we have. Back in the 70s, when a lot of new plants came up, there were 125 reviews that they did initially in the licenses that they put out. Now those plants are reaching the end of their license life, which is usually 40 years. And now they're doing what they call extensions, and they're doing 94 of those renewals have been occurring. So 125, 94 still have a big industry that's out there. But the NRC is not the only regulator or the only governmental agency that regulates nuclear. The Department of Energy is another one. They have their own sets of facilities. They do other types of work, maybe not power generation, but they do other types of work at those facilities. But there's also the military, for instance, or other governmental organizations. The U.S. Navy is very large. They have about 83 nuclear ships right now, and they regulate themselves, if they will, and what they do within that. And they're actually coming into a big part of their cycle where a lot of those Navy ships are starting to age. So they're having to look very closely at how they're going to go forward. So these are the different types of regulators in the U.S. Overseas, you got similar types of setups. But one important thing that's occurring right now within nuclear is there's a transition to the next generation of technology. And talk a little bit about that, but as part of that, there's new plants that are coming out. They're highly digital. They got a lot more software in them. They're new technology. They're going to be licensed for a longer life. They want to keep these probably for the rest of my life and probably the rest of your life with extensions that these new plants will be operating. And the software is going to be a very important part of it, which is why we want to talk about this. And I like to think about it of the transition that's happening in the industry and why this is a kind of a slow situation. If some of us might remember 30 years ago when in aviation you got on an airplane and they were analog airplanes and pilots were up there at their yokes and they had cables and they made their airplanes fly and you looked in their little gauges and stuff, much not unlike a nuclear control plant you might go in today. Now they're digital. You know, they got flat flat panel displays. They got push buttons. They still have the things to fly it, but they're digital. And the plane or the computers fly the plane versus the pilot flying the plane. That's kind of the transition that's going on with these new plants. So with that will be a lot of different operator approaches to things. You're going to be more of a system manager instead of a operator, if you will. So what's required in quality assurance? Facilities that are regulated by the NRC, we got about 100, 96 right now. I think last time I checked, there were a little over 100 a few years ago. About 20% of the electricity in the U.S. comes from nuclear power. That varies depending on where you're at in the world. You go to France, more like 80%. Other countries, very little. But we're about 20%, so we have a mix. With that, 31 research and test reactors that are right here at NC State. You'll see that there's other activities, though, that the NRC regulates besides the big ones, which are the power plants, research and test reactors. They do a lot of work in fuel transportation area, spent fuel, new fuel, that type of thing. They also work in areas like sources for things like radiography, different types of manufacturing type areas. And then there's a large component that goes into medical devices, if it's a nuclear type of medical device, chemotherapy type sources, things like that. Sometimes that's a shared responsibility with a state, so a lot of the states do the health type work. The area I worked in when I was at the NRC, I worked on the new plant area, and we handled the supply chain aspects for the new plants and the new plant licensing primarily. So that's the area I know most about, because that's just where I work there. There's also new plants coming on board. We have 2 new plants in Georgia. The Vogtle plants are coming on board. They're in the middle of construction right now, about 80% complete. They're down close to Augusta, Georgia. And so that with a Watts Bar plant that was in the Tennessee Valley area that came on board a couple of years ago, the new plants at Vogtle will come on fueling next year, I think, and operational in 2021. So there are some new plants activity that's occurring, which is coming from the nuclear renaissance we were talking about earlier, which had about 25 plants that were going to happen, and we ended up with a handful as all that happened there. So there are some new things in the U.S. Overseas, a lot more going on. So just maybe right now is a low cycle. A lot of it has to do with the price of natural gas and other things. So just kind of a lower cycle in construction. But as far as those regulatory requirements that come down, I want to talk specifically about the quality assurance parts. And the biggest one we're going to talk about is 10 CFR Part 50, Appendix B. And if you think about what is these numbers, and whenever you see like numbers like 10 CFR, that's the Code of Federal Regulations, and every industry that's got regulations generally has a CFR associated with it. So if you think about the nuclear area or the NRC regulated area, this 10 CFR is Title 10, and if you were to write it down, it goes in about 2 books like this, a couple inches thick. Those are all the regulations that the NRC is in charge of. And of this mass of paper, very little of this has to do with quality assurance specifically. There's all kinds of things like what kind of reporting do you do? How do you apply for a new license? Lots of things like that. How do you take care of your employees? Those kinds of things. So there's lots of regulation the NRC is responsible for. But this would be the Title 10 part. And then the quality parts in the Appendix B to Part 50, and if you were to take all the quality assurance requirements, you could put them on a piece of paper like this. So it's a double-sided piece of paper. It's kind of small, but you can read it if you got good eyes. And we'll talk more about what's on here. So you go from all the regulations to the quality assurance requirements. You can see these are very high level as far as what you need to do. So what we had to do was go out to the industry and say, hey, we need some details about how to do the quality assurance. So ASME is one of the industry standards that's used, and they have NQA1, it's a nuclear quality assurance standard for quality assurance, and they came up with producing detailed standards that meet the NRC requirements. So you go from NRC high-level requirements to more detailed requirements in the industry standard. And we're going to talk more about what the specifics are in a minute. But that's the quality assurance requirements. There's other requirements. Another one you'll hear about maybe is Part 21, which has to do with reporting problems or reporting defects. If you were to be operating your reactor here and something unsafe were to occur, there might be a reason to have to report that to the NRC, and the NRC would take that information and potentially share it with other groups that have similar situations that may came up, because we want to keep the industry as a whole safe. So there's a sharing of information. But there's other requirements that go with it. 3 Mile Island had a lot of lessons learned that came out of that incident in Pennsylvania, and so there's a lot of new regulatory requirements that came out of 3 Mile Island. There's things like we call station blackout. If a power plant were to lose the grid power, which is what they use actually to operate their equipment, if they were to lose that grid power, what would they do to compensate for that? Usually emergency diesel generators or something like that. So that's called station blackout. There's fire protection requirements. There's technical specifications that are required. There's maintenance requirements. There's lots of requirements, and a lot of them are regulatory. But the main one for quality assurance is this Appendix B, which we're going to talk a little bit more about. So these would be the 18 criteria that make up the nuclear extra, or you might call it the 18 criteria that are printed on this page in a regulatory language, or the what we call requirements in ASME NQA1, the basic requirements. This is the 2017 version of the latest one's been published. They do about every 2 years. This particular version has the basic requirements of these 18. It's probably, let's say about that little part in the front, very little as far as the written. And then there's more requirements that say, hey, if you're doing certain things, these are the things you should do. That's like a little bigger part. And then all the stuff in the back is like guidance stuff of like, these are things you could do. There might be good practices, the best way to do it, that kind of thing. So this has a little more information in it. But the 18 criteria are the same. They matched them up to make it easy. And to give you an idea of some of the things that go into this nuclear extra, for instance, it might make a company that does nuclear work different than a company that just does maybe work for the medical industry or just general type work for you as a customer. Organization. We have a very structured organization. One of the big themes within that is independence. There's a lot of independence that goes between if one person does work, we have another person that's independent do checking of that work. That's a common theme. Specific requirements for things like training of your personnel, especially when you get into something called auditing, which is the 18th one down there. When you get into that, we have specific requirements for auditors and what they do. But there's many other things. Design, how you do design, how you verify your designs in there. A big chunk of the requirements go with procurement, because if you're operating a nuclear power plant, you're Sharon Harris down the street here, they probably don't make a lot of stuff. They got to buy it. So they got to go out to the supply chain and say, we need a pump, we need a valve, we need services from someone. So there's a big part in here about how they buy those services and how those are controlled, both from what you tell the supplier in your purchase order to what you do when you get those components in and verify that they're of good quality. Another common theme that goes with these is we write things down so that we can do things in a repeatable method. So you have written instructions, we have written documents. We train our people, and hopefully we can give them a document that will show them how to do things, where some of the industries, it's all here and the really senior guy knows how to do everything and he tells everybody. Well, we write it down in our industry. Things like tagging. We tag components so we make sure we're using the right things. We tag systems, or we identify them so we make sure that we're doing what we need to with the proper systems. Another common area when you get up to numbers 10, 11, and 12 is we do inspections. Inspections of documents, inspections of components coming in. We do testing, and when we test, we use what we call M&TE, which is measuring and test equipment that is calibrated to industry standards. And we do that to make sure that we're actually testing to the right standards. So that's kind of a little bit different than some industries. And then the last area I kind of talk about is, well, what do we do if things come up that aren't as they should be? Well, we call that quality assurance going in action. If you have a non-conforming item, for instance, in a manufacturing, you need to correct it or correct how that was made. We have non-conforming requirements. Maybe you have processes that need to change within your quality assurance program. We have corrective action processes. And of course, we like to keep lots of things written and or electronic in the records form so that our auditors can come by and look at that later to make sure that we're doing things right. So all these things together, the 18 requirements, if you will, put together help us do the nuclear extra. Just out of curiosity, has anybody seen these before? A couple people? People who worked in quality assurance probably know it or do audits. Know that because they have to kind of know what it specifically says. Let's talk about a couple regulatory concepts. The first one I want to talk about is this top line, basic components are safety related. If you ever heard of something being most critical, it's probably in a nuclear plant, it's called safety related. The technical term might be, it's a basic component, it's a pump, it's a valve that is very critical to the operation of our plant. Well, most people probably in a plant couldn't tell you how it became safety related. They just know it is safety related. It's been designated a pump or a valve or a system as safety related. Well, this is why it's safety related in a nuclear plant, because it's related to one of these three things. One, it's either something to do with the integrity of the reactor coolant pressure boundary. So in a plant, you're circulating coolant, and there's a pressure boundary that typically goes with that. So that integrity of that boundary, so we're not spilling that coolant. That's the first one. Second one is we want to be able to shut down the plant and maintain it in a safe shutdown situation. That's the second one. And then the third one is, in certain cases, you might have accidents or other events that might cause you to release something into the atmosphere, to the ground, or that might affect your local populace or your employees. So we want to prevent that off-site exposure. So when you step back, and the people at the high-level design have to be really aware of this because they designate systems as being most critical, safety related, because of these three areas. So when something is safety related, we give it the highest amount of quality assurance. And the highest amount of quality assurance requires us to actually apply those 18 criteria to the design and manufacture of all those systems and components. Well, we can do that. The plant's not going to do that, but the supply chain will. And so they'll go to the supplier and say, you have a nuclear quality assurance program, and supply us all these nuclear components. That's one way to get your components. Another way, if you can't do that, if you have to go to a commercial vendor, is we do this thing called dedication, commercial grade dedication, which is a way, an accepted methods of taking something that's commercial, maybe an ISO product, or software that's commercial, or calibration services that might be commercial, and we deem them equivalent to something that was made under that nuclear quality assurance program, because your vendor has to have the nuclear quality assurance program to be nuclear. So that's what dedication is, one of the methods to bring in commercial items, services, or software. But one thing we do is we grade the risk that goes with our systems. And when you grade something, the highest risk things get the most rigor, if you will, within quality assurance, and the less risk items get less rigor. We apply the quality assurance standard to all these things maybe, but we would, just the amount of rigor that we would put in with it might be different. To give you an example, if you're a power plant and you got your nuclear reactor and it's making heat, which turns water into steam, which the steam goes and turns a turbine, and the turbine makes electricity. Well, the nuclear island, or that nuclear part, the steam generation part, that is probably a lot of that safety related. When that steam may go to the turbine, in some cases, the turbine, which to a utility is the money maker, that's what's getting the electricity out, a lot of that may not be safety related because it's not related to those three things that are up there. We care about more of that safety capacity of the reactor. So that's an example of something that's probably $100 million to buy a turbine, but it's not even safety related. Really important though, because the plant's kind of useless without the turbine out there. So that'd be an example, for instance. One thing that we haven't talked about is software yet. And software, you have to go to more in the details. You're not going to find it. Oops. You're not going to find anything about software in here, but you will find stuff about software in here. So we got to go to more of the details to get into the software. NQA1, if you were to follow this, is actually kind of more oriented. There's software parts in here, but it's actually more oriented to structures, components, big things like valves and systems and things like that. But it still applies to software, and we'll see how that goes here in a second. Okay, so to bring this all together, there's a flow down of quality assurance requirements. We start from the government, goes to a licensee. So a licensee might be a nuclear power plant. It might be NC State because you have a test reactor. And then it even goes to supply chain because you got to buy your pieces from there or services from there. So we talked about how Appendix B from the quality requirements gives the 18 criteria. Typically, you go through like an industry standard like this, and you say to your licensee, via their license, which is part of the NRC licensed activity, which I think right now, there actually has some NRC folks here today talking about licensing. So that license exists with those organizations that are allowed to operate within the nuclear industry from the NRC. Part of that's the quality assurance program. So that's the QAP, if we will. And that licensee is going to do that grading, if you will, and manage the quality program, and will determine what's safety related based on how they operate and what's not. Some things might be just purely commercial, non-safety over there, but then there's this one in the middle that's augmented quality. You might hear that term. That's something that has additional quality requirements, maybe like 3 Mile Island requirements or something else that's really important, but it's not safety related, because safety related is those 3 things. So the licensee then wants to go out and buy things from the supply chain, and they would issue a purchase order, the red line over there to the left, and that quality assurance requirements would then be put down to the vendor, who has another quality assurance program that meets nuclear requirements, and they can buy things directly from the vendor fairly easily once the vendor has the nuclear quality assurance program. If they don't, then you got to do something called this dedication, and there's 4 methods for doing that, which I really won't go into, but you can get things that were commercial and deem them equivalent to nuclear produced things by using dedication. Or if it's maybe not safety related, you just do other things, and there might be other requirements that go with it. But that's kind of how it flows down into the industry. So now let's take a step back and talk about computer programs or software and how we apply these requirements to software. Well, from a regulator standpoint, the regulator's concern or regulatory concern is, does it affect the safety of your plant, which is those 3 things we talked about? Or is it part of your license that you said you got to do something? So, for instance, let's say you're operating a nuclear plant and you have a valve, and a valve is a big chunk of metal, and you can open it and you can close it, and maybe there's a controller that does that. Well, the whole valve may actually, even though it's part of a safety-related system, may not be safety-related. For instance, maybe the valve just has to hold the pressure and not leak the fluid that's in it. Well, then maybe the pressure retaining part of it's safety-related. The fact that it opens and closes and the flow rates are certain things, or it does it in a certain speed, may not. It may be important, but it's not safety-related. So it's very important that you focus on what's the safety, or what is the part or the system or the component, and how does it affect safety. Usually the highest safety has to do with, from a software perspective, is things that are embedded in safety systems. So if you have a sensor or you have a controller that has software embedded in it that makes it operate, that's probably, and the operation is safety related, that's going to be the highest level of safety. It's interesting that when you look at NQA1, it's actually a little different. If you apply this standard, it just says it's things that must be essential to the safe, reliable, or efficient performance of a nuclear facility. So that's a little broader. And the reason I bring that up is on the nuclear plant side, if you're an NRC plant, they're talking about that regulatory part up there. If you might be on the DOE side and you're working on DOE side, you might have broader things that you need to apply this quality assurance requirements to because NQA1 says it's broader, and that's the way what they use. But generally, embedded items or things that are a physical part of a structure, system, or components, highest risk, highest application of NQA1. Then we get into things like design. Let's say you got to design the base mat, the concrete that goes under a plant. Pretty important, the concrete's of the right strength and the right thickness and everything, so that might be a design element that's very important. And then anything that goes with the plant, operating it or process control can be very important. Those are usually kind of highest levels, if you will, going down. Some software considerations. One thing is that software is a little different than a component. If you're a manufacturer, you might be a manufacturer, you're making something, and you're going to check it, you're going to test it, and you're going to ship it. If you're a software producer, you might do something like development, you're going to do some sort of testing, and you're going to send it out. There could be different ways that you send it out. It's a little bit different because you got more of a development side, and as we all know that software is usually not perfect when we get it, so where components hopefully are as close to perfect as we can get them, at least especially in nuclear. So there is a little bit of a difference. NQA1 is more oriented to the components, but there is software elements that we're going to put in there. And to get those elements, you really got to go to a certain subpart, that's what SP is, in NQA1 called subpart 2.7, and that gives you your software controls. It's probably about, about 20 pages long in here. So 20 pages long says you how you do software that's developing software or using software, either one. Could be either one. It's not all inclusive though. NQA1 won't go into some areas like malicious intent, cybersecurity, those types of things. Not going to find them in here. Important, you got to do them, but they're just not in that standard. So it gives you a lot more information on how to do software, and that's where you would find it. Another area, if you were interested, dedication has another subpart, 2.14. But those would be probably the two areas that you would apply that are more directly applied to software. The risk will vary. I said the highest area would be like an operational embedded type of application. Next would be design and analysis. And then you go down to lower levels like test software, manufacturing software, software that runs those machines that make things less reliable. And then you come even down to a research and development type of application, which I think you do some here. And there's a specific subpart that's in guidance in NQA1 for R&D that takes like more of a theoretical kind of approach to things and how you would apply NQA1 to that. So there's the big gamut within NQA1 as to how you could apply it. Grading, though, and the knowledge of the application is the key. So if you're a licensee or a user of this, you really got to know what's important about what you're using so you can properly apply your quality assurance requirements. And the reason I want to tell you this is because there's a huge difference between a very risk-based type of system like a control system, an instrumentation control system that might operate a plant, to go down to the other types of lesser software. So let's take a look at the worst case and give you an idea of how much rigor would have to go into your instrumentation and control system producer. Well, you have something called a life cycle, which is the software development cycle, how you go through, develop, test, that type of thing. There is a life cycle documents that you would have to conform with. IEEE, you probably heard of IEEE standards. IEEE has a couple that would apply to the overall life cycle of developing software. The NRC takes a industry standard like IEEE and they put their blessing on it through what's called a reg guide or an RG. And they say this reg guide endorses IEEE standard for software like life cycle activities. And with that, there might be things you need to produce like a management plan, a software management plan, a project management plan. So that's kind of the overall umbrella, but no, it gets a lot worse than that. Well, if you have a life cycle for INC, you might have all these different phases you go through in your software. from conceptual through design, through testing. You check it out, you retire it. So there's different phases potentially. And then there's reg guides for all those phases. And then there's IEEE standards for all those reg guides. And then there's documents that come out from everywhere from requirement specifications, development, design documentation, verification plans, and reports on down. So to give you an idea, if you're an INC very high risk type of software, there's a lot that goes into it. And you probably have a very large dedicated staff to do this. So let's not talk about that because that's way too complex. Let's talk about a use example. And a use example would be something like maybe you do electrical sequencing in your plant from your emergency diesel generators come up when they come up, and you have to reload your system by making sure you don't overload your generator by sequencing on your various systems. So it might be something as simple as that. So how would this work? Well, there's two areas that you would focus on. One would be the acquisition, how you get that software, and then what you do with the software once you get it. Those are the two main areas. Your software program, your quality assurance program is going to control all those software activities. Again, you're going to focus on what is the safety effect of this, and then you're going to go decide you're going to buy this software because you're probably not going to produce it. So you're going to buy it, and you're going to buy it from either a single source or multiple sources, and you'll have to figure out if that software is going to work with other types of software. You're going to have to figure out how you're going to control that, and you might go through a dedication type of process with that. There'll be quite a coordinated effort that would go into the acquisition between your procurement people, your engineering staff, your quality assurance people, to make sure that you're making sure you're meeting your safety requirements when you're buying that, and the supplier can supply what you want, and it will properly function for you. So that's part of the acceptability is once you go buy it, you got to make sure it really can do what you want if it's important. Once you get it in, you're going to go through configuration management, and you're going to have to decide things like, are you going to do any programming of it? Are you going to allow vendor updates, which are changes to it? So this first couple, you have to control any changes that occur. And another thing that's important is most software applications have to exist with the system software and hardware. So you might have to consider, you will have to consider your safety, the effect on safety from the system software and the hardware. And to give you an example, just the other day, I have an operating system that got updated on my home computer. I used, basic things like Word, Excel, all those things. The operating system update now causes the applications to crash about 25% of the time. So even though the thing I care about is the application, the Word, the Excel, for instance, the system software affects it, so it has to be part of the whole quality assurance approach. But it's much easier when you're a user because you can define exactly what you want to do and how you're going to buy it. And if you could buy it nuclear from a quality assurance program that's got a nuclear pedigree, it's pretty simple. But if you got to go commercial, it gets a little more complex. Another example, maybe, there it is, would be you're a developer. So there'd be more aspects of your quality assurance that would get added in if you were a developer. Again, NQA1 tells you what to do, but now you're going to do things much more in depth, and there's going to be a lot more of them because you're going to do a lot more in the software development. Again, QA program will define things. You're going to have to focus on an area, either if you're going to make software for a user, what we call user limitations and specifications, or if it's going to go in a product, like a controller or some sort, it would have to be part of the design of that. So you have to really define what those specifications are, and you would do a lot of grading in this as the developer organization. But acquisition is still probably going to be important because you're probably going to end up buying things like software tools, system software. You might have things like drivers that go with it. There might be other things that you need to make the software operate, even though you develop a certain part of it. So you're still going to probably have to do acquisition, and you're going to develop this and test it under a lifecycle, which I'll show you an example in the next slide. And your configuration management will be much more robust to the point of you will identify all the configuration items, specific things that you're going to control. You're going to very tightly control how you change things. and you're going to do statusing when you go through that, in addition to considering your tools, your system software, and the hardware that goes with it. So it's going to be more robust. Lifecycle, there's a lot of leeway within developing organizations, what they use for a life cycle. It could be a waterfall, which is kind of what NQA1 does, which is what I showed you a few minutes ago with all the colored blocks in it. But it could be spiral or other types of development methodologies. It could be an agile methodology, which a lot of software companies are using. All that's allowed, but the main key is you have to have key elements as part of the quality assurance program, and I'm kind of showing you some of them here. One, you're going to have planning documents that say who does what, who's responsible for what, when's it supposed to occur, those kinds of things. You're going to have specific requirements for the software, which will go through the design, and then that's going to drive your testing so that you can go back and make sure you met your requirements. And then we have something called verification and validation, which is verifying that either a phase has been satisfied or the end product has been satisfied. And as I mentioned, independence and approvals go with that. One of the biggest areas, producing that user documentation, because if it's for a user, you want to let them know what the limits of what you put into your software. It could be very different. The limits for the nuclear application may be different than what the software can do overall. You maybe only have one module, for instance, or one type of calculation that the software will do, and that's the nuclear part, but the software does 99 other things. Well, you need to make that clear to the user because they can only apply it for a safety-related activity if it's designated as such, and that might be one little part of it. So you're probably going to need a software-specific quality program. If you're a software company that does developing, probably your software quality assurance program is your quality assurance program. But there's a lot of companies that do both software and they make components, and sometimes they have two. One would be the components quality assurance program, and one is the software quality assurance program. And the reason they're different is because with software, you have a lot more things like reviews and approvals that go with the development. You have things like problems and errors that occur all the time, so you have to handle those. And then there's a lot more documents and records that go with it. So usually it's pretty different. So what I tried to take was a few minutes to give you details, and nobody's head hit the ground, which is good, on the software, but kind of flow down from what's the regulatory requirement down through a quality assurance program, which would exist at all the licensees or plants or organizations that are blessed by the NRC to operate, and then how that might go to a supply chain, and specifically for software, what's some of the extra stuff that you need to do to give you a feel for it. So that's kind of what I covered. There's a lot of different areas in there. So if people have questions, I'm happy to take them now. Yes, sir? Oh.
One of the things that might be relevant to these guys when they go out that you didn't cover is if you're doing safety analysis, all of these requirements go on whatever you got installed on your desktop. It all hits it if you're going to do any kind of safety analysis for your plant.
That's correct.
That's the way it is, for real.
Yeah, it's safety affecting. So it could be you're affecting an application, a basis for license, or the actual pieces that go in the plant that do those three things. So there's many areas that go into safety. The NRC spends a lot of time making sure safety is well maintained within the industry, even though it's a little part of a whole plant's operation. Other ones? Yes, ma'am.
Safety regulations generally aimed at preventing reactor core meltdown, right?
Mm-hmm.
And so for these new type reactor, molten salt reactors, the reactor core is already melt. So in your opinion, how will the safety regulations change?
Okay, so the question for anybody online that couldn't hear it was, how do the regulations change when you focus on safety and the core melt, for instance, with a new generation that might be like molten salt that might have a different type of core, and how that would be applied? Is that the question? Okay. Right. So, yeah, there's very different approaches. And so the three I showed you up here is the three that are typically applied typically applied in the U.S. industry right now is light water reactors. So there are new technologies, modular reactors that are out there now. NuScale's making one. There's advanced ones beyond that. They get into things like molten salt, micro reactors that have different technology in their core. And with the different technology, it requires a different approach. And so the shorter answer would be, it would be different. It would not be exactly what was up there. That's for a light water reactor. But it would probably be similar because basically you want the reactor to maintain a safe shutdown, and you don't want to release products into the atmosphere or the ground. So they'd be similar but modified, and even the licensing processes for the new reactors are very different now than what they used to be for light water. And almost all our plants were built in the 70s and 80s is when they were built, and that was kind of the plant of the day was the light water reactor back then, and the plants that are going in now are advanced light water reactors. Modular reactors are light water reactors also, but they're little smaller ones, and the next one would be more along what you're saying, and that would be different. But there will still be potentially safety affecting components that would need to have more control. But the good thing is, to pontificate on that, is if you look at an old style one like down in Sharon Harris, for instance, when something bad were to happen, they have to control the plant, they have to shut it down, they have to keep it cool, they have to keep water circulating, for instance. The newer plants, I'm gonna make this easy, it might not be exactly right, but in worst case would be with a new generation of plant, maybe we can walk away from the plant after it's shut down for 72 hours and it will be just fine. That could be an example for the next generation that's going in now. The later generations, the advanced ones, they're supposedly fine all the time, for instance. And you don't even have to keep pumps circulating and things. Things are natural or radiant cooling. So a lot more advances in safety. Yes, ma'am.
So would you say that the majority of people that work on quality assurance of software that has to do with reactors, do they have most of their background in software development or nuclear engineering?
Good question. The best answer would be for them to have both would be a software background. That would be the best answer because you can pick up the nuclear parts from it, the application, if you will. Probably realistically in the industry, quality assurance people tend to be generalists. So they tend to maybe don't have a very specific expertise. They more are good about looking at the way processes are occurring and finding if are they actually following the processes they're supposed to follow, and if they're not, who do I go talk to find out if that's a problem, kind of thing. So I would say realistically in the real industry, they're generalists with a technical background usually, so that they can understand the technical aspects. It does become very tough in software though, because it's tough to find people that that work in software. First of all, it's hard to find people that have that broad knowledge, and it'd be very hard to find people that know nuclear software on top of it. So interested and you have a technical background, you're probably qualified if you get in with the right group. Anybody else? If anybody wants to, another question comes up later, here's my email. I have some cards up here if you'd like to come pick up a card. Happy to answer questions. Things come up later. Don't do homework, kind of past that stage, but if I can help you with anything, I'd be happy to hear from you. Thank you very much. Nobody?